The word average refers to a single number used to describe a collection of numbers. Now, you may have calculated average in the past. You may be familiar, for example, with your average of 7 math tests. You've taken 7 math tests, you want the average, and you know how to make the calculation, probably. But when you arrive at an answer for the average of those 7 tests, it is one number, and that one number kind of represents the collection of all 7 tests. Well, there are actually 3 averages that we're going to be talking about and calculating here. They are mean, median, and mode. The mean is the one that we're most familiar with and what we generally refer to when we use the word average. Let's take a couple of examples. Suppose we have these numbers and they represent miles per gallon ratings for 15 cars. It's important to notice that we have 15 items here, because when we calculate the mean, we are adding all of the numbers and we're dividing by the number of numbers that we have. For example, in calculating the mean, we represent mean as x bar. So x bar is the mean, and it's calculated as a ratio or a fraction. It's the sum of all of the numbers that we have before us, and we divide by the number of items that we have. So if it's those 7 test scores that I talked about, you would add all those test scores up here, and you would divide by 7. You see, and if we're talking about the information that we have here, then we add all of these miles per gallon ratings. You see, we add all of those together in the numerator, and we divide by the number of items that we have. We have 15 automobile mileage ratings over here, so we're dividing by 15. Now, the sum in the numerator turns out to be 420. In the denominator, we're dividing by 15. So 420 divided by 15 is 28. So x bar, the mean, is 28 miles per gallon. Now, median and mode are different kinds of averages. Median generally is the middle item in a group of items. And mode is the model item, or the item that occurs most often. So for median, and I'm going to put middle here, that's a good reference for the word median. But what you have to do to find the middle is to arrange the items in some kind of order, the order from largest to smallest or smallest to largest. Now, I've listed them smallest to largest here. All 15 items are listed. And when they're listed like this, it's pretty easy to identify median and mode. Now, there are 15 items. So let's see. We want the item right in the middle. Here's the first, second, third, fourth, fifth, sixth, seventh. I think it would be the 8th item. I think it's this item, because at this point in this list, we have 7 items above, 1, 2, 3, 4, 5, 6, 7, and, 1, 2, 3, 4, 5, 6, 7, and we have 7 below, 1, 2, 3, 4, 5, 6, 7. So this is the item that is distinctly in the middle. Now, so the median here is 27 miles per gallon. All right, the middle item. Now, you might be thinking, well, gee, we have an odd number of items here. We have 15 items. So there will be one that is distinctly in the middle. But what if I take one off? What if I have only, and let's do that here. What if I have only 14 items? You see, then there will be no particular item that is right in the middle. I'm just going to erase the one at the bottom, all right, whether you can see it or not. I'm erasing the one at the bottom, and now I only have 14 items. Which one is the median? Well, the median, the middle of this whole group, is right in here. You see, it's right there. There are 7 items above this dotted line and 7 below. So what then is the median? Is it 26 or is it 27? Well, it turns out in a circumstance like this that you take the mean of these two, that you want to add 26 and 27 and divide by 2, you get 26.5. So the number right in between these two will be the median. So that kind of tells us that the median doesn't have to be a number which is in the set of data. You see, we can actually make a calculation, and it can be between 2 of those data items. All right, let's go back to the set that we had before. We identified the median as 27, and I'm going to put this 39 down at the bottom again. And now let's talk about mode. Now, the mode is the item that occurs most frequently. And sometimes the word model is used to describe mode. And we can see in the list, let's see, 21 occurs twice. 25 occurs 3 times. And let's see if any other item occurs more than 3 times. Well, 25 occurs 3 times. It occurs most often, so the mode is 25 miles per gallon. So we have a mean, a median, and a mode. By the way, some sets of numbers have no mode because, after all, if each item occurred only 1 time, then we could say that every one of them was the mode. Or we might have a set of numbers which is bimodal. That is, we have 25 occurring 3 times. Well, what if 31 occurred 3 times as well? So we'd have 2 numbers for the mode, you see. So a lot of different circumstances can occur involving the idea of mode. So mode is the model item, the item occurring most frequently. Median is the middle item in the entire set. And to identify these two, it's important to put the numbers in order. Sometimes an average can be a little deceiving. For example, the average annual temperature in San Francisco, California is 57 degrees. The average annual temperature in St. Louis, Missouri is also 57 degrees. And yet the climate in those 2 cities is very much different from one another. Now, to see the disparity in temperatures, we can use a graph called a box and whiskers plot. And here's how that is accomplished. Suppose we take the temperatures of St. Louis, the average monthly temperature. This would be January, February, March, April, May, June, and so on for every month of the year in St. Louis. And then we arrange these numbers in a particular way. We want to write the numbers in order. So the smallest number in this whole group of numbers is 39. The next highest number is 47. There's a 47 down there. It's listed here, and so on. So now the numbers are written in order. And in writing them in order, you know that we can identify median and mode. We're going to need median in this structure for the box and whiskers plot, as we'll see in a moment. But these are the important elements that we need in order to construct the plot. We need the smallest number in the group, and that's the number 39. Pretty easy to identify. We also need the largest number. On the end over there is 89. The median, the middle item. Now there are 12 of them. Let me count from the left. 1, 2, 3, 4, 5, 6. So the median is right in here. There's 6 numbers above, 6 numbers below. So right in between 72 and 76 is the median. Now to find the median, we would add 72 and 76 and divide by 2, and we would find that value to be 74. All right, now we need a couple of items we haven't talked about. The first quartile is designated as Q1, and it is a number corresponding with the median of this group, actually. And let's see, right in the middle between these 6 numbers would be a number which is right in here. And that first quartile number then is the average, the mean of these two. Between 47 and 49 is 48. So 48. Now the significance of a first quartile number is this, that exactly 1/4 of, or 25% of the data values will lie below that first quartile number, the first quartile. All right, now we need a third quartile. Third quartile. Now, you know, it's the quartile idea corresponding with the notion of quarter. We are just dividing the group of numbers into quarters by identifying median as the middle, and then the quartiles, the first and third quartiles, you see. So we're just creating dividing lines among the numbers that we have before us. All right, third quartile. Now that's nothing more than the median of this upper group of numbers. And there are 6 of them, so let's see, 1, 2, 3, so it would fall in here. So let's see, between 85 and 88. You see, we want the mean of these two, so we would add them and divide by 2. It turns out to be 86.5. So 86.5 is the third quartile, designated Q3. Now, one significance of the third quartile is that 1/4 of, or 25% of the data values lie above that third quartile, the third quartile number. All right, here's how we use all of this information. First of all, we look at the smallest number and the largest, and we make a number line starting at 39 and going to 89. Okay, I've done that up here. Here's 39, here's 89 way over here. All right. Now I identify the position on the number line of the other significant numbers that I have in the list. The largest number, the median is 74. Let's see, 69, 70, this would be, now these differ by 5, the little marks here. So 69 and 5 is 74. Oh, 74 is right here. All right, so here is the median. And I'll write its number. All right, 74 is the median. Now, we need those quartile numbers as well. First quartile is 48. Let's see, here's 49. So 48 would be right about here, and it is the first quartile. The third quartile is 86.5. Let's see, 79 and 5 is 84. 86.5 is about right, let's say about right here. And that is Q3. Now, look at what we're going to do. We're going to make a box like this. And that's why this illustration then is a box and whiskers plot. You see, box and whiskers plot. And it gives us a pretty good idea of the disparity of numbers, how the numbers differ from one another in the entire group of information. Let's do the same thing for the average monthly temperatures in San Francisco. Now, we said that the mean, or the average temperature, is 57 degrees. But here are the monthly numbers going from January through December. And placing the numbers in order, I get these values. And now I have listed all of the items that I listed above. Let's make sure we understand how we arrive at these. The smallest number is the 57 here. The largest number is the one on the end, the 74. And then the median, let's see, the median, there are 12 items. 1, 2, 3, 4, 5, 6. Right in between 64 and 68 is 66. Now, the first quartile is a number, and it is a number which is in between this third item and fourth item. Between 60 and 60, that's easy, it's 60. And then the third quartile is out here. I'm counting over 1, 2, 3. So it's between 71 and 73. That would be 72. So with this information, let's go and make a box and whiskers plot. We slide over here, and I'm going to try to make it correspond with the box and whiskers plot up here for the temperatures associated with St. Louis. Now, the smallest number is 57, and that's roughly right here. The largest number is 74, and that's about right, it's here. And it gives me a number line, 57 to 74. The median is 66, and I'm kind of looking up here. That's about right here. So here's the median. And then the Q1, the first quartile, is 60. That's right here. And the third quartile is 72. Gee, that's way over here. And now the box and whiskers plot. And what we see from this, we see a lot more than we just see or just know by realizing that the average temperature, the average annual temperature in the two cities is 57 degrees. We know that for St. Louis, you see, we have a much greater disparity in temperatures than we do for San Francisco. And we also see that there is a greater disparity below here in this second quarter of the temperature, a bigger range in temperature values here than in any other part of the whole group. We see a rather consistent range, however, for San Francisco above and below the median.